we do x squared plus y squared equals r squared. Go ahead and, squared. We get our circle centered at the origin. Now, once again, the idea with the circle is that the equation comes directly from the distance formula. And so another way you can think about this is, r is our distance. And we only need x squared and y squared because to get the distance, we're doing x2 minus x1 and y2 minus y1, but x1 and y1, the center, are 0, 0. So in order to get a circle that is not centered at the origin, we just go right back to that distance formula and say, oh, well, now I want every point that's the same distance away from some other point. And typically when we're talking about that some other point, we're going to use, as our x and y coordinates for that, we're going to use the letters h and k. Anytime we translate things, which means we transform them by shifting them vertically or horizontally, we say the amount of those shifts we use are h and k. So I'm going to do x minus h, square that, and then we will do y minus k. We'll square that. I will go ahead and add sliders for both of these. And just so you can see this, I'm going to add a point here, h comma k, which will be the center of our circle. Now, right now, we have a circle with a radius of 3.2, and that is centered at point 1, 1. And we've done that by subtracting 1 from x before we square it, and subtracting 1 from y before we square it. And we're still setting that sum of those squares equal to the radius squared. So we're still asking for all the points that are equidistant from this center. In this case, the center is now 1, 1. So that's how we get how we move the circle around. So your h value, which is connected with your x value, your h is what's going to move it left and right. So as h increases, we're going to move the circle to the right. And as h decreases, we're going to move the circle to the left. Similarly, our k is what's going to shift the graph up or down, and that's always the value that's associated with y. So as we increase k, the circle moves up. As we decrease k, the circle moves down. Now it's important to remember that the way I wrote this was with these values x minus h and y minus k. And so when I make h a positive value, right now it's 2.8, in the equation it's going to be x minus 2.8. So you always end up having to, when you're given an equation and you're asked, oh, what's the center? Where's the center of the circle? You always have to change the sign of that value. So let me give you an example here. So let's now change this to, let's go ahead and turn this off. So +1, and then make this -5. So now the question is, where is the center of this circle? Our radius is still 3, but where is this circle centered? And the answer to that is, because it's x +1 and y -5, we've shifted to the left 1 and we've shifted up 5. So we changed the signs of what's in here with our variables, and the center of our circle is at -1, 5. Go ahead and plot that so you can see it. So here's our circle. The equation is x +1 squared plus y -5 squared equals 9. Has a radius of 3, and it is centered at the point -1, 5. So that's kind of a fun thing to know, is that you can shift circles. They don't always have to be centered at the origin. We just use this form of the equation where it's x minus h squared plus y minus k squared equals r squared.